So welcome to this seminar on the top 10.1 features of Windows Server 2012. Now this is my top 10 features of Windows Server 2012 after speaking to a lot of customers about their challenges, their initiatives, and then when I talk about what we can do in Windows Server 2012, these are really the top 10 things that I found really get their attention. Now a lot of these I just actually finished a new book, so Microsoft Virtualization Secrets, where I cover a lot of the Windows Server 2012 technologies, not just Hyper-V, remote desktop services, other core changes to the operating system. And hopefully out of this you'll just get a taste of the power that is there in Windows Server 2012. But remember, this is not everything. There are many other things that I just don't have time to cover in a top 10. Great new IP address management capabilities, DHCP failover capabilities, huge amounts of features just that are now part of the operating system. But let's get started. So you're going to see this key message about Windows Server 2012 is the definitive platform for the cloud. It's not just saying private cloud, it's not just saying public cloud, it could be hybrid cloud, it's on-premise and off-premise. And the key part here is that Windows Server 2012 has really taken all of the learnings Microsoft has gathered from its many years in operating systems, from its many years as an application provider, a service provider, providing services in the public cloud. Think of Hotmail, think of Office 365, think of Xbox Live, think of Windows Azure as a platform as a service and all its software as a service capabilities. All of those lessons have really been brought in to Windows Server 2012 to provide you a platform which includes an operating system, it includes a hypervisor, but also key capabilities in the application platform to really make this the definitive platform for any type of cloud, on-prem, off-prem, hybrid. And when I think about those, the first thing I like is Server Core. Now Server Core was actually introduced back in Windows Server 2008. It was the preferred and default installation option now in Windows Server 2012. And the reason people have not really used it very much up to this point was in Windows Server 2008 and 2008 R2, you had to make this choice when you installed the operating system. Do I want Server Core or do I want a full server installation? And if you've never used Server Core, essentially Windows Server shares a huge amount of code with the client operating system. So Windows Server 2012 has many of the abilities of Windows 8. This is great. Also, with each new version of Windows Server, more and more capabilities are added to the product. Again, this is fantastic for the end customer in terms of all these capabilities are now in box. But there is a side effect. It makes the operating system bigger. More disk space, but depending on who you talk to, disk space is fairly cheap. But it also means now there's potentially more I have to patch. There's more I have to manage, and with increased patching potentially comes additional reboots and potential larger attack surface. So Server Core was a version of the operating system that's the same underlying OS. It's still the same kernel, all the same core OS capabilities like event logs and performance counters, but it didn't have all of the upper layers. So for example, it didn't have Internet Explorer, it didn't have Explorer.exe. You're running with basically a command prompt for local management. Now in 2008 R2, they added the ability to remotely manage Server Core through Server Manager. So that made it more accessible, but it was still a choice you made at installation time. And many people were afraid of this because they're not used to managing server from a command prompt. They're not used to setting up initially from a command prompt. So the big change in Windows Server 2012 is the graphical interface, and indeed the management tools can be added or removed at any point in the operating system's lifecycle with just a reboot required. And again, if I look historically, Server Core traditionally requires about 50% less patching than a full server installation equivalent, and far less reboot, because many of those patches it doesn't need in the past were maybe about Explorer.exe, which required a reboot to change them. Now this is actually a Windows Server 2012 server over here. You can see it's got Server Manager running locally. I have my taskbar, my system tray, you can see I'm a Windows Server 2012 Standard Edition. Now, what I can do in here, I'm actually going to do this locally, but I could do this remotely as well. I'm going to make this a server core box. So I'm going to remove the graphical tools. I'm also going to remove the management infrastructure. That's a new change in Windows Server 2012. What I can do now, if I wished, I could remove Explorer, Internet Explorer, but leave the graphical management tools and infrastructure. I could still have Server Manager available to me. I could still have MMC, control panel applets, available to me, but I just remove the graphical shell. But I'm actually going to take it all the way back to a pure server core. This will then go off and reboot the box. So I'm going to let that run in the background. This ability to add and remove the graphical interface really opens up a lot of new capabilities though. If you consider in the past, those concerns of using server core were, well, initially it's too hard to set up without a graphical interface. Well, now you can. I can install the server with the GUI, which is now what it's called, server with a GUI, and do all the configuration. Then once I'm done, going to remove roles and features and remove the GUI, remove the management tools. It's that easy. If I hit a problem one day and I'm really not good at troubleshooting without a graphical interface, I can go and add the graphical interface back, or just add the management tools back, troubleshoot, and then remove it again. This is the default installation mode in Windows Server 2012. If you just click next, 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 you will end up with a server core box. And the whole driver in 2012, and I'm going to talk about this in point 2, will be you want to be remotely managing this. And again, I'm going to go into more detail. What's great now in Windows Server 2012, basically every inbox infrastructure role is supported on Server Core. Additionally, there's a shift. In Server 2012, Server Core is not just something that you use for infrastructure roles, i.e. inbox roles like a domain controller or file and print. It's now an application platform as well. For example, SQL Server 2012 will run on Server Core. Future applications will run on Server Core. And Microsoft is really working closely with its partners to make sure those applications will run on Server Core going forwards. So that machine has now come back, and notice it's now a command prompt. This is Server Core. I can't run Server Manager. I can't run Internet Explorer or Explorer. I do get Notepad, so powerful graphical utilities. I do get Task Manager. And you'll notice we really simplified Task Manager in Windows Server 2012. It was far too complicated previously, giving a lot of information people just didn't need. So now we just show very, very basic applications. I'm kidding. So click more details and you get this nice heat map. So it actually shows you all the stuff we had before, but it makes it easier to see who's actually using up all of the resource. I can see performance. So it's the same key operating system underneath is the key point here. I have 2 control panel applets, date and time and international. These were too complicated to create a command line equivalent, so they kept the control panel in there. I don't know if that's true, but these are the only ones you get. But I can still manage this remotely. So the key point here is this doesn't matter. It can be running my infrastructure roles, it can be doing everything I need, but I manage it all remotely from my Windows 8 machine or a Windows Server 2012 box. Now, I still have PowerShell. So let's say, for example, now I actually want to go back to, let's say, the server management infrastructure. I don't want to go back to the GUI, but I want to actually just jump back and have Server Manager locally. So I can just add back the management infrastructure, and that's going to reboot. Now, when it comes back, it will still be command prompt as the shell. It's not going to put Explorer back or Internet Explorer, but it is going to give me all of my management infrastructure back. So wait for this to reboot, and then we can see this middle configuration level. So it's not just server with a GUI and Server Core now. I have this middle layer of management infrastructure and tools available to me. And when you think about using this in your environment, you should try and get to server core. Every server should be server core. But maybe you've got some applications that have dependencies on parts of the management infrastructure. So now I can install that management infrastructure back. Some applications maybe hook into Explorer, so then you would have to run server with a GUI. But over time, you'll be able to get back to server core, ideally. Now, while that's actually going on, there's another change. Reduced footprint. So traditionally, actually if I go far, far back, if anyone ever administered Windows NT 4, you will remember the pleasure of every time you added a new role or component, you had to reinstall the Windows Server media. It would copy the files over. If you installed a service pack and then added a role or feature afterwards, you would have to not only insert the media but reinstall the service pack. It was a fairly painful process. Well, this disappeared in Windows Server 2000, and the reason it disappeared was the big change they made was they copied the entire installation media to the hard drive into this side-by-side assembly folder. So now when I add or remove a role or feature, it just links it essentially from this side-by-side folder, so everything is always on disk. When I apply a service pack, it patches everything in that folder, whether or not it's installed or not, effectively. So that's great in terms of my manageability and ease, but it does use some extra disk space. Now, going back to my previous comment, disk space is normally not a huge challenge today. So the ease of management is worth using up a couple of extra gigabytes. But there are some scenarios where that disk footprint may matter. Imagine I have 100 IIS servers in a network load balance farm. They're all running server core, and all they're running is IIS. Well, I'm probably carrying 5 or 6 gigabytes of extra disk footprint I really don't need. If it's always going to be this IIS web machine, why do I care about all of the other parts? Now it can be removed. So it's possible to actually remove things from that side-by-side assembly, remove it from that disk footprint to effectively shrink it down. Now again, this is not something you want to do for everything. This is for very particular needs if the disk space is really a problem. But there are functionalities built in that if you do want to add a role or feature you've removed from disk, by default it can just go and grab it from Windows Update. Or you can point it to a folder on-premise, maybe a network share you have. It could be the installation WIM, or you could expand the installation WIM to a folder, or just point to another server's side-by-side assembly. And I can change that location via group policy. So it's just giving me even more flexibility. So now I'm back at that server where I added the management infrastructure and I'm just logging on. So you can see I still have the command prompt. It looks exactly the same, but now after I log on, Server Manager is there available to me now. It's doing that automatically. It's firing up Server Manager. I also have MMC. So I can add and remove the various snap-ins. I still don't have Explorer. I still don't have Internet Explorer. I do have additional control panel applets now. So I have the standard system control panel applets, etc. So this is now, it's server core, but with all the management infrastructure and tools available to me locally. And again, I can manage this remotely. When I think about this server, if I fire up Server Manager and I look at my servers, I'll see that server there. If I look at my test servers, there it is. If I do a refresh, there you go. I can still go and talk to that server. It's available to me. So full remote management, even though it's in that server core mode. Which brings me to the next point, point 2. The power of many, the simplicity of one. And this is a huge shift in Windows Server 2012. And I think in some ways it's going to take people the longest to really get used to. Because we've not changed the way we work for a really long time. If I think about back in the early days of Windows and any kind of server, servers sat in a data center. And administrators would go into the data center. They may use a KVM switch to connect to multiple servers. They would connect to a server's physical box, manage that operating system that sat on that physical box. then they would connect to a different box, etc., etc. With virtualization, we moved those operating systems onto fewer pieces of hardware, and instead of maybe using a KVM, we used remote desktop protocol. But nothing really changed. We carried on managing one operating system instance at a time. And even Windows has not really helped to move past that. If you look at Windows Server 2008 R2 and Server Manager, it could manage one box at a time. That's really all you could do. Server 2012 completely changes that. Server Manager has been completely redesigned and is based around now managing groups of servers. So you have to change the way you think. You cannot just try and duplicate what you did in 2008 or 2 into 2012. Well, you could, but you're really not getting the maximum capabilities. The goal here is I add multiple servers. I can manage 5, 10, 100 servers as if it was one. Now let me actually just fire this up on my machine. So this is Server Manager. So I look at my dashboard. I can see different groups. Now I have many servers on this box. Got some domain controllers, some Hyper-V servers, some remote desktop servers. I have a cluster and some just temporary boxes. It's detecting what services are actually installed and breaking them into various groups. I can see which ones are domain controllers, which ones are certificate servers, which ones are Hyper-V boxes, which ones have IIS running. I created my own manual test server group, so I can go in and create my own group of servers. So I might create Data Center A IIS servers, Data Center B IIS servers. So you can really manage this whatever way you want. I create those. And then at a high level, I can see this dashboard. Let me zoom out a little bit. I can see a nice basic health of, well, how are all these servers doing? So I can see they're all healthy, apart from, well, DNS has got some best practice analyzer results. I can click that, and I can see what the actual problem is. It's showing me all the information from those different boxes. I can see I've got a service issue on one of my test servers. And if I look at all my servers, I've got 9 services are not how they should be. From here, I could do Control A, and I could just start them all. So I'm managing many servers, really as if it's just one. And that's the key point of this, really making it easy to manage. You'll notice here, I have a 2008 R2 server as well. I can have 2008 R2 and 2008 servers. All I have to do is install the Windows Management Framework 3.0 on my 2008 and 2008 R2 servers, and I can manage them from the Windows 2012/Windows 8 Server Manager. So this is not just management for my 2012 boxes, this is really making me easy for me to manage all of my 2008 and above servers. And it exposes all of the various functionalities here. I mean, I can actually select a particular box, for example, and I could go and configure its NIC teaming. I can run some PowerShell against that box, bring up its computer manager. And I can manage the services within these various service-specific boxes. So I can go and look at all the storage pools that may exist over the various boxes I have. In reality, I don't actually have many defined on these servers. But if I did, I could view them all. So if I just do Control A, and I look at my storage pools, yep, I have very basic information here. But it's going to go and poll, and I'll find some others over time. I can go and view all the disks from all those different servers. So it's giving me a very easy view of what's going on. If I select all my servers, I'm going to see a sum view of everything, all of the events across all those boxes. So it's showing me, hey, there's warnings. Well, maybe I don't want to see that. Let's take out the warnings, for example. And I can actually filter in a more granular level on that. That just took out everything. I can look at all the services. Maybe I just want to look at event log. So it shows me the event log from all the different boxes. I can see all the best practice analyzer results. All those boxes. I can see performance information about the various servers that I've got available to me. So very, very quick, easy views of what's going on in my environment. Now the key part here is I'm not running that on any of the boxes. Remote management is enabled by default on Windows Server 2012. So if I just go and install Windows Server 2012, remote management is enabled by default. So I can just fire up Server Manager and manage it. Now that is not saying remote desktop protocol. RDP is very different from remote desktop management. But what it does allow me to do is fire up Server Manager and manage that box without doing anything else. And so here's the next shift in how I want to manage. I want to manage remotely for everything. I want everyone running Server Core. If everyone's running Server Core, I can't run Server Manager locally. I want to run it on a Windows 8 box, which is going to give me that full management. So the remote server administration tools are available for Windows 8 to manage Windows Server 2012. They are only available for Windows 8, so this follows the normal cadence of remote server administration tools. For 2008 R2, they were available for Windows 7, 2008 available for Vista, etc., etc. And that's what I'm doing. So all these demos I'm showing you, I'm running Server Manager on my Windows 8 box. This is exactly where I am right now. If I click Start, I'm running on Windows 8. And this is the Server Manager I'm running within here. So I'm running all of this exactly as you should be doing in your environment. So the new Server Manager is great. It's a fantastic way to really manage multiple machines, as I talked about, with the simplicity of one, but it's still something you're doing graphically. It still does limit to a certain extent what I can automate, what I can just make happen behind the scenes. PowerShell really drives everything that we want to do in Windows Server 2012. If I think about true orchestration, if I think about making things just automated behind the scenes, provisioning servers, automating tasks, I need to be able to do that in a scripted fashion. I need to be able to do it from a command line. PowerShell v3 is introduced in Windows Server 2012, and it really lets me do everything. There are more commandlets for Hyper-V alone in Windows Server 2012 than there was in the entire Server 2008 R2 operating system. Now, one of the key things that we hear about PowerShell v3 is least cognitive distance. What that means is if I think of what I want to achieve, what I want to perform, that is what the command would be. So if I want to, I don't know, get a VHD, the command will be get VHD. Now the challenge is, so I have so many commandlets, how do I actually manage those? So one thing that's introduced, let me jump over. So we have a new PowerShell integrated scripting editor. So this makes it very, very easy for me to create PowerShell scripts and even run commands. So what I can do in here is, first of all, it gives me a nice little help area. So I can go and search for, well, show me all the commands related to a VHD. Great. But imagine I'm just typing get dash, it's got IntelliSense. As I type, it starts showing me the possible commands that I may want to use. As I carry on typing, it shows me the parameters. So it's helping me, and it shows me the value it's expecting. But there's even more than that. One of the great things I can do, if I do select a command in here, it's actually going to show me all the parameters. So I can type in the parameters in here and then make it insert what the actual command would be. It creates it for me. And I can see the normal help, but this is really just a help that's shown if I do a get help in PowerShell. But it makes it easier to view. But this is a fantastic place to start off with PowerShell. It's really going to help you understand what is achievable, what I can do. And I can run these commands on many, many servers at once. So this is a key thing. If you do not know PowerShell, go and learn it. It's at the cornerstone of Windows Server 2012. It's at the cornerstone of System Center, Exchange, and most third parties for their hardware, for their apps, they are delivering PowerShell modules to help in its management. Storage innovation. So this always gets a bit of a storage, really. Yes. Huge changes in the storage in Windows Server 2012. So SMB, the protocol we use for file sharing, connecting to a share, which up to this point we really think of as that protocol we use to access our Word documents, our PowerPoint documents, and really not much else. It's undergone a huge change in 2012 to really move beyond just somewhere where we store our documents to a true file-based enterprise protocol. So I can now use this to run and store Hyper-V virtual machines from. I can store my SQL databases on an SMB3 file share, and it works fantastically. Now, how is this possible? Typically, when we think of a file share in a cluster, we have an NTFS formatted LUN, and one node in a cluster mounts that LUN and offers that file share. But if that node went down, that file share would go down. There would be a period of time of an outage. I would lose my handles, my locks, as that another node in the cluster saw the node was down, took the LUN and reoffered the share. Windows 2012 allows an active-active configuration, so I can now have 8 nodes in a cluster, all offering that same share at the same time. They're all mounting that same NTFS LUN using the cluster shared volumes technology that was introduced in 2008 R2. So they're all accessing the same volume at the same time. They all offer the same share at the same time. I can do transparent failover. I can move between nodes in the cluster, i.e. the node I'm using to access the share, without losing my handles, without losing any locks, with no downtime. Additionally, let's say I'm connected to one of the nodes in the cluster. When I connect to node A and say, hey, I want to access this file share, node A says, sure, but also I'm part of a cluster. Nodes B, C, and D are also in this cluster. And I, as the SMB client, will say, thank you. I would then connect to node B as well. I would say, hey, node B, I'm currently connected to node A, but do me a favor. I want you to tell me if node A goes down straight away. Node B says, sure. Time passes, and node A does go down. Node B sees that very, very quickly. It's part of the cluster, and it proactively reaches out and tells me as the client, hey, node A has gone down. Connect to me instead. And so that brownout period that I would have got waiting for a regular TCP/IP timeout disappears. There's literally no impact on those SMB clients anymore because it's actually proactively reaching out and saying, hey, there's an issue. Come and connect to me instead. There's multi-channel and receive-side scaling capabilities. So if a server has multiple paths to the file share, it can use them all now instead of just one. So it's going to get increased bandwidth. Advanced hardware like remote direct memory access, it works with SMB, so it can bypass having to use the CPU and just directly talk between the networking cards. VSS provider for remote file shares. If I am storing my data on remote file shares, I still need to be able to make sure I can back it up in a consistent and consistent way. I can do that. So what this means now is, this is just a Hyper-V example, but I can have a standalone host or a file over cluster storing their virtual machines on a 2012 SMB file share. This could be SQL databases. This is just one example. But that's not all. There's a new concept called storage spaces. So storage spaces actually allow me now to take local attached disks. It could be direct in the server or maybe a storage enclosure, and just kind of group them together into a space and then create volumes on top of all of those disks without worrying about which disks are being used. I can do thin provisioning. I don't care what the physical underlying storage is. I can really just go and create whatever I want. So if I jump back to my server manager and I go to my file and storage, let's just look at one server. So you can see on this one server I have storage space called data. And you can see right now I have a lot of disk space available to me. I have 3 disks in this single space, and I have just a single 200 gigabyte volume created. Now I've used thin provisioning, so it's only using 1 gigabyte of actual disk space, but behind the scenes it could go up to 200 gigabytes, but I could change that. So that's me looking at that storage pool. You can see there's 3 disks in that storage pool on Hyper-V 03. but it's also showing me the storage pool on Hyper-V 2. So here I only have two 300 gigabyte disks, but I've got a 5 terabyte volume created using mirroring. So obviously this is doing thin provisioning as it shows here. Now, as long as I stay ahead of the actual allocated and in use by adding more disks into the storage pool, I have no problem. So I can create huge volumes now and just add storage in as I need to, staying ahead of the usage. If a disk has a problem, and let's say it is a mirrored or a parity, which is one of the options I can do, if I go in here I can say new virtual disk, I select the storage pool I want to create it on, again over all of the different servers available. So I might want to create it on that scratch drive and give it a name. And I select, do I want simple, mirror, or parity? And if a disk does fail, as long as there's spare disks available, it will just repair automatically. How it stores the data, you don't know. It's spreading it over all of the various disks available, but it's ensuring its integrity. And providing there's sufficient spare disk available, it will repair if there is a disk failure and let you know. So that's just one of the features. Storage pools. File system error checking. So many organizations today, they will limit how big they create NTFS volumes. And the reason is, if the volume has a problem that has to be fixed with check disk, they have to take the volume offline. Check disk works by taking the volume offline, searching the disk for problems, and then fixing them as it finds them. And the reason I've got this row closed is, the analogy here is that if they want to fix some potholes, they don't know where the potholes are, but they know the road has some potholes. They would close the entire road, start searching for it, find a pothole, fix it, then go and search the next pothole and fix it. So the road is closed for weeks or months or years, as it seems to be in Texas sometimes. And that's how check disk works. It would take off the entire volume, search, fix, and it could take hours or days to fix. In 2012, that's changed. In 2012, it now works by searching for the problems while the volume is still online. It doesn't take it offline. It finds where they are and just marks, here's a problem, here's a problem, here's a problem. And then, once they've all been found, which may still take hours or days, but it doesn't matter because the volume stayed online, then it takes the volume offline and spot fixes those specific problems, which is a maximum of 8 seconds. An analogy there would be this, the traffic's still going, and they're actually fixing the potholes after they've already found it while the traffic is still flowing through. So it's going to be very, very quick. Instead of being offline for weeks or months, this road is closed, they're doing it as the road is still open. And I can show that. So on this server, I have a volume called Scratch. And what I'm going to do is, I've introduced a problem on this volume. I have a corrupt file. So it's corrupt and unreadable. So if I do a get volume, I see it needs a scan needed. So I'm going to do a scan of that volume. Now notice, while it's doing this scan, the volume stays online. It's not taking the volume offline for anything. It's just basically going to perform that in the background. So it's running the scan, it's doing the checking. There's no outage. I could carry on using that volume however I want. So it's found errors. So now if I do a view of the volume, I can now see it needs a spot fix. So at this point, I'm going to tell it to do a spot fix on the volume. Now this will take the volume offline. Now depending on how quick I can be, so I couldn't show it, but it went offline. So there would have been an up to 8-second interruption in what was going on that disk. Now it's healthy again. when that bad file is gone. So it did the fix. So that's the new capability of the new check disk or repair volume. It can do it while the volume is online. All of that scanning that might take hours or days, and then just fix it in under 8 seconds. And if you use cluster shared volumes, which introduces another layer of abstraction, there'll be no downtime at all. So that was a big change in check disk. Data deduplication is now available in Box as well. So at a block level, it would do dedupe on the data on the volumes. So if, again, I can jump to Server Manager, I can see my volumes. So it's scanning through, and I can actually see here on my Hyper-V, zoom in, I have dedupe enabled on my data volume. I've saved 1.1 terabytes through data deduplication. And it's on a 1.8 terabyte volume. It's only used 400 megs in total. So that deduplication is huge. If I look at the properties, I can see that 73% deduplication rate. So that's going through all of the data and performing a dedupe on that. Now I have it to run periodically. So rather than it constantly running in the background, I've actually got a schedule. So I do not enable background optimization. Now you can do that, and it will just run when it's not busy, and it will go and scan through and look for duplicate data. But I have it running basically at 10 PM every night for up to 6 hours. I could set a second schedule as well to go and search. But at those times it will go, scan for those duplicate blocks, and just store them once. Now I can say ignore any data that's not older than 5 days, for example. Maybe I don't want to bother deduplicating data that's still frequently changing. I might exclude certain types of data, exclude certain folders. So I have complete control of how this works and how I want to use it in my environment. There's an iSCSI target just built into the operating system now. There's an NFS v4.1 server built into the operating system. New ways to actually control how data is accessed using dynamic access control that lets you set policies in the domain and then apply them to file servers, not files, not folders, but the entire server. And then based on the classification of the data and attributes of the user or their method of authentication, it grants if they have access and how the auditing should be performed. So really completely changes the way we manage audit and security on data in Windows Server 2012. So this is just kind of summarizing. So if you think about all those capabilities, storage spaces, new SMB, iSCSI, great NFS server, dedupe, thin provisioning, easy error checking. I didn't even talk about ReFS, the new resilient file system. You can build a very powerful storage platform just using Windows Server 2012. Maybe you got those remote locations and the SAN is not economically viable. Use Storage 2012. I mean, even some environments may find, hey, this can actually do everything I want from a SAN. But if you have a SAN, this is a great way to expand its reach. Let's say it's got a fiber channel SAN. Well, SANs can be expensive to connect to in terms of fiber channel HBAs, the port switches required. Now, I could actually put a Windows 2012 file server cluster in front of the SAN. Everyone else in the data center could access via SMB3, which is back-ended by a cluster shared volume running on the SAN. 10 gig data center network, and let's say a 4 gigabyte fiber channel connection, you're not going to see a drop in performance than if they were natively accessing the SAN, which is huge. Think about really extending the reach of your storage area networks, if you have them, to really more places in the data center that previously may not have made sense from a finances perspective. Remote desktop services. So this is a huge amount of change in terms of simplicity, and there's a driver for a lot of things in 2012 around making it simpler. But this, I think, in terms of management, is the simplest. So I'm actually going to jump over. Now, I could absolutely do this remotely. I could set all of this up remotely from Server Manager, Right now I can fire up Server Manager, and from here what I can actually do is I can manage, add roles and features. We have a new option for remote desktop services installation. This is only RDS has this today. And I can say, do I want to do a standard deployment or do I want to do a quick start? But what I actually want to do is I actually want to do it directly on the server, just so you can see everything that's going on. So this was a box I just added the graphical shell back to. And I'm actually going to say I want to add roles and features. I'm going to repeat exactly what I just did, remote desktop services installation. I can do a standard deployment. Standard deployment is I can say there's 5, 10, 20 servers. And this one wizard will configure all of those servers for all the various roles: connection broker, web access, virtualization host, session host. And they'll be configured to the best practice and integrate with each other. I can do a quick start. Quick start says do everything on this one box. And I can do VDI, or I can do session based. Now, VDI is very popular right now. I'm well aware of that. But often people say VDI, they don't really mean it. They understand VDI because there's great marketing out there. But if you hear the words lockdown or task worker, it probably doesn't need to be VDI. It probably can be session based, which is going to give exactly the same end user experience, but you're going to get 5 times more users on the same piece of hardware, because they're sharing a server-based OS instead of lots and lots of client virtual machines. But the great part is there's both. Both of them are just in-box in Windows Server 2012. So I'm going to do a session-based desktop deployment. I'm going to select on this local server. It's going to go do and check it has the required pieces that it can actually run this. Say yes, restart automatically, and go. That's it. That's how easy in 2012 it is to actually go and stand up a new VDI or session host deployment. And what this is going to do is search for all the programs locally available in this box and publish them with app publishing. So it was a huge advance made in sort of Windows Server 2008 in terms of capability of the in-box session virtualization. There was a gateway service to encapsulate RDP and HTTPS. There was driverless printing, app publishing, a web front end, huge functionalities, which is really all being brought together. So all of this management can now be done through Server Manager and PowerShell. I just showed that scenario deployment option, which performs all of that configuration on all of the various servers. Session and VDI improvements in terms of scalability, performance, ease of use. And if you are doing VDI, because VDI is a great solution for power users, developers, people who need to change the OS, reboot. Those people need their own OS environment. They can't share an OS. Well, now I can have a template virtual machine, and the inbox VDI will duplicate that. I can update that template and it will refresh the deployed VMs out there with that new template. There's a software rasterizer. So if I do have more advanced graphics, and Windows 8 does that, it can use the CPU for graphical rendering, and it works very well. User disk for personalization. So if you talk VDI, if you talk session virtualization, that's a very, very small part of the overall solution. That just gives me an operating system. The user environment is their data, their profile, their applications. So I need other technologies like roaming profiles, like user experience virtualization, like AppV, like folder redirection. But let's say I'm an organization that really just doesn't have that yet. I don't have roaming profiles or user experience virtualization. I don't have AppV or app publishing. User disk is a way to basically have a VHD file that can store the user's profile and data. And within a specific pool, i.e. a VDI pool or a session virtualization pool, their data and settings are stored on that. And it will automatically disconnect and reconnect when the user logs on, so it follows them. They have a consistent experience. There's a new easy setup of remote app and desktop via email auto discovery. So if you use Exchange ActiveSync on your phone, you'll be used to being able to type in your email address and password, and your email is just set up. It's done. Same thing works with remote app and desktop now. You type in your corporate credentials, it will find your remote desktop server, and it will find all the applications for you and just publish them to your desktop. Very, very powerful. Remote FX everywhere, and I'll explain in a second why we had a slightly different transition. Remote FX was introduced in 2008 R2SP1, and it allowed basically a physical GPU in a server to be virtualized. So if I look over a Hyper-V, and again I'm doing this all from my Windows 8 box, I'm doing all this management remotely. If I look at my Hyper-V settings, I can see I've got physical GPU, and it's actually virtualized with Remote FX. The virtual machine I'm actually using for this presentation is using dynamic memory. You can see it's actually using quite a lot of memory right now. I have a Remote FX graphical adapter assigned to it, which is why I can do these nice graphical transitions. I'm actually connected via RDP. I'm running all of this from an RDP connection. Just to show you that, this is all running within a remote desktop connection window. Everything I'm doing here is within RDP. But it's been improved. It's been made to work over wide area networks. Adaptive graphics, so depending on the bandwidth, it can improve the graphics as time goes on based on the bandwidth available. Multi-touch support. USB redirection, not just for VDI but for session host. So that allows me to take any USB device that basically exists. So let me fire up an MSTSC. If I look at my options, I can basically map with Remote FX any USB device. It doesn't matter what it is. It can be multifunction, anything that's connected, I can map it through. So that's now available. So I just turned on an Xbox 360 controller. Why? So I showed you the PowerPoint. I showed you the nice rendering, the PowerPoint, and you've seen these 3D rotations that go between slides. That was to just, in the background, be showing you the graphical capability. But what I find works really well to show the graphics is something a little bit more powerful. So this is Lego Batman 2. And what I want to do is I'm going to fire this up. So notice it's doing the audio as well. It's running in the background. So this is DirectX 11 rendering on my Hyper-V box and just sending the pixel updates over the screen. So I can just quickly save, continue. Start breaking things. So I know the Riddler's hiding in there somewhere. Now again, this is not a gaming technology. My goal is not to show, hey, look at the great games I can play with Remote FX. But it does give you an idea of what is capable. If I can do this for a game, think of everything else I could do.
Hide and seek, Batman!
This is bidirectional audio, so again, if I had a microphone, I could do live meetings and everything else using this technology. So it's not just USB devices will come out of that. And again, just to show, this is all running in that remote desktop connection. This is all using Remote FX coming over the RDP protocol. No trickery going on. So quit out to that. So the scenarios this enables, think about those live meetings. Think about two-way video conferencing. Those advanced PowerPoint sort of graphics I've been using for this presentation for the transitions. Oil and gas industry have sort of fairly advanced graphical applications. So do many, many other industries. I can now use all of these in my virtualized environment. So let me jump back to my server that I kicked off in the background. I can now look at the virtual machine and see that it's currently going through the final configuration of the remote desktop services role setup. So it's configuring that, it's going to spit out the session collection, it's going to create for me, publish the applications, and it's going to give me a URL. And that's then publishing via a web portal all the applications available on this box. Now it's just doing that final scan, and I'll be up and running. And there's my URL, Scratch 22. Now it's going to use a self-signed certificate. So now what I want to do is I'm going to access this through my Windows 8 box. Just jump to that. It's going to get an error about the certificate because it's self-signed, that's fine. It's going to use forms-based authentication. So I'm going to log on with my user account. There's my applications. Click on Paint. It's going to fire up a session remotely on that server, and here's Paint. Look how smooth it is. Now if I look at detail, I can see it's actually an RDC connection running Paint remotely on that server. So that's how hard it was to set up app publishing with a nice web portal using Server 2012. Very, very simple to do. Active Directory. So Active Directory continues this theme of simplicity, making things easier. Upgrading a domain, I can now do on a single box, providing the account has sufficient permissions. I don't have to jump around the infrastructure master, the schema master. Much, much easier to do. Virtualization safe domain controllers. So one of the challenges we have with domain controllers and virtualization is people create snapshots. Snapshot is a point-in-time copy of a domain controller, or any virtual machine for that matter. Its storage, its memory, etc. If you apply a snapshot to a virtual machine, you put that virtual machine back to that previous point in time, which for a domain controller is catastrophic. Domain controllers expect time to only ever go forwards. They have update sequence numbers, which are used to track replication with other domain controllers, used to create security IDs for objects. So if I'm a domain controller, and I'm update sequence number 1, 2, 3, and someone creates a snapshot, then I carry on using number 4, 5, 6, 7, 8, etc. Then someone applies that snapshot, well suddenly I'm back at USN 3, and I'll try and reuse it. So I've now got duplicate security IDs. I'm now not replicating correctly with other domain controllers. I get a replication bubble. And it's a big problem to fix this. So Windows Server 2012, Hyper-V introduces a VM generation ID. This is a GUID that, if anything changes the virtual machine's view of time, it could be a snapshot is applied, it could be a virtual machine is copied, it would change the VM generation ID to a new value. So Active Directory uses this. Windows Server 2012 domain controllers constantly compare the VM generation ID it stores in the Active Directory database, the ntds.dit, with the VM generation ID being given by the hypervisor every single time it tries to write. If they're different, it knows someone has messed with its view of time. It will dump its RID pool, invalidate its invocation ID, which is like its database identifier, is how it controls who it's replicating with. So it will start re-replicating correctly again. It won't risk overwriting objects. So it protects it from snapshots being applied. This same technology now allows me to clone domain controllers. A domain controller can have a special XML file put in place to basically say, hey, I'm going to be cloned. I can then just take the VHD of that domain controller and copy it 1, 2, 3, 10 times. When that copy starts up, it knows it's got a different VM generation ID than what is stored in the database. It sees this XML file telling it you're about to be cloned, so it knows I'm the clone. It runs a mini sysprep process, And I can now stand up many domain controllers very, very quickly. Where this is very useful is think disaster recovery situations. I have a problem, I need to stand up many servers very quickly. I can do that with this technology. Active Directory based activation is another great feature. So people use KMS today. It's a way to activate Windows and Office applications internally without having to go out to the Microsoft clearinghouse. But you have to have a KMS server, and that server can fail, I have to replace it. Active Directory based activation is for Windows 8 and Windows Server 2012, and instead of having servers, it places an object in the Active Directory configuration partition, which is part of the forest. Windows 8 and Windows 2012 servers will just passively look at that value. If it's there, they activate. No minimum number of servers or desktops required, they will just activate. Now, you will still need KMS for your legacy operating systems. The Windows 7, the 2008 R2 and previous. But for Windows 8, Windows 2012, next version of Office going forward, they will use this new Active Directory based activation. Now, there is a Windows 2012 domain and forest mode, but it's not needed for anything. There are really only two features in Windows 2012 that even require Windows 2012 domain controller, which is dynamic access control and group managed servers accounts. So managed service accounts were introduced in the previous versions of Windows Server as a way to have an account that's used by services as their logon without having to worry about resetting its password. A managed service account automatically syncs its password and resets it to whatever the security policy is through the MSA. So between the AD and the account, it automatically synchronizes. But can only use it on one machine at a time. Windows Server 2012 group managed service accounts can be used by multiple boxes. So that's kind of the new feature. So you have that network load balance farm. They can now use a single MSA. Another nice thing is the new Active Directory Administrative Center. So I'm actually just going to show this. This was available in the previous version of Windows, but what it's done is it's extended its functionality. So think about the recycle bin for Active Directory. We had this ability in the previous version of Windows. I could enable the recycle bin and then recover objects that were deleted, but there was no graphical interface. I can do that now. So I go and look, and I'm going to delete a user. I never liked the green arrow. I can now go to my deleted objects and I can search. And it's done. So very easy access to restoring objects that have been deleted. I have a PowerShell history window. Everything I do in the GUI, it's trapping and telling me the PowerShell. So now I can go and create users, groups, set parameters, whatever. Do it once in the GUI, capture all the PowerShell, and then put that into a script. So now I can automate it through something else. Fantastic feature. Fine-grained password policies were another great feature that allowed me to set different security policies such as password complexity, lockout settings for different groups of users. But to do it, I had to use ADSI edit, which was very, very painful. Now I have a graphical interface. I can go to my password settings container, which I would just find under System, Password Settings Container, and I can create password settings. It gives me a nice graphical interface to set all the various parameters, say who should be applied to for this new policy, and I'm done. So a nice interface for us to use. Group policy has gone through a similar capability. Obviously there's additional group policy settings for Windows 8, IE 10. There are new rules for packaged apps, so the Windows Store applications, formerly would have called them Metro applications. The focus is on using a tool. Group Policy Management Console now has all of the separate tools we used to have to use built into it. So it's easier to troubleshoot, report, do management. I can remotely trigger a group policy update now on an organizational unit just through the graphical interface. And I can be more granular with invoke GP update PowerShell commandlet. If you look at group policy though, there's really two parts to group policy. There's the part that's replicated as part of sysvol with DFSR replication. And there's the part that's stored in Active Directory. And they can get out of sync sometimes. Well, this can now be monitored and checked through the Group Policy Management Console to just give you a good idea of the overall health of group policy. Number 7, better with Windows 8. So Windows Server 2012, there's a huge array of technologies that really benefit the client operating system. But the two I really think about is sort of branch cache and direct access. So branch cache, there's far simpler deployment now. I don't have to create Office-specific group policy object telling it the servers to use. It will just discover it. Automatic client configuration, pre-population. Direct access is so much simpler now. So in the past, we would use User Access Gateway. It enabled us to use IPv4 through protocol translation. It has wizards to really simplify setting it up. That UAG technology has really been absorbed into the core Windows Server 2012 operating system to make UAG much, much simpler to actually set up and manage now. There are additional features. I can now actually have a geographically distributed direct access deployment, and that's now fully supported, so clients can go to the closest direct access point using them. So great features with Windows 8. When I think about application services, so one of the key advantages here is a similarity of tools between the on-prem and the off-premise. So if you are using, for example, Windows Azure, the platform as a service, or even infrastructure as a service, I can use the same tool set to create applications for my on-premise Windows Server 2012 or my Azure platform as a service. Common tools, workflows, so it makes it easy to do. But I'm not an app developer, I'll be totally transparent, but the feature I really liked was when I talk to clients, there's a pain point around IIS. I have these huge farms of IIS servers, and certificates are actually a big problem. If there's a new SSL certificate, I have to deploy that to hundreds of IIS servers. In Windows 2012, I can change that. I can set up a folder, put my certificates in the folder, and then all my IIS servers can basically subscribe to that server. So when new certificates are put in that folder, they will automatically read them in and start using them. So far, far easier for certificate management. Coming up to the closing stretch, so failover clustering. Windows Server 2008 really changed clustering. 2003 was painful. 30, 35 dialog boxes to create a cluster, painful to manage. 2008 completely changed it. Validation to just check, hey, this cluster would be supported. About 3 screens of dialog to create a new cluster, and that was really just asking for an IP address if you weren't using DHCP, and a name. Completely different. 2012 builds on that. So now we have one-click patching of an entire cluster. So if you look at this picture, I might have 3 nodes in a cluster. When I want to patch it, I click a button, and it will go and work with Windows Update or Windows Software Update services, evacuate one node, so it would use live migration to move all the VMs off or whatever other resources are running, patch it, reboot it, bring the services back, then do the same for the second box, then the third, then the fourth. Very, very easy now to patch an entire cluster. It's a great feature. Virtual machine priority. So imagine I do now have lots of different virtual machines. Some are high priority, some are medium, some are low. Well, I can now actually set those priorities. So when a node goes down and they have to move the VMs, it can start the high priority ones first, then the mediums, then the lows. I can do preemption. Maybe there's not enough resource left on the cluster to start them all. Well, it can shut down lower priority VMs so I can start the higher priority VMs. We have dynamic quorum. I don't talk about this on the slide, but dynamic quorum helps me change the nodes, votes in the cluster. So if I take a node down for maintenance, I don't run the risk potentially of shutting down too many nodes for maintenance and the entire cluster just collapses because there's not enough votes. It will remove votes as I put nodes into maintenance mode to basically protect it. Health monitoring of virtual machines. This is an interesting one. So the idea here is, let me just jump over to the failover clustering tool. So again, it's still running for my Windows 8 box, as really everything I've been doing on this demo is. I have a cluster. I have a single VM running on this cluster. I can select it, and I can now do something called monitoring. So I'm going to go and query that VM. So it needs to be a Windows 2012 VM, and I've enabled the virtual machine monitoring firewall exception in that VM. I can now tell failover clustering to, hey, keep an eye on these services. And the way this will work is, within the VM itself, you can set restart functionality if a service fails once or twice or 3 times or whatever. So what this is now telling it to do is, look, for this print spooler service, if it goes down once or it goes down twice, just restart the service in the VM. On the 3rd time it fails, Hyper-V would now reboot the entire VM. Because as we know, a reboot will fix any problem. So I'll just reboot it. And I would show the app is in a critical state inside clustering. If it failed again, it would actually move the VM to another node in the cluster and restart it again. So we now have the ability to actually monitor basic health monitoring of services running within a VM and basically bounce it if it fails a certain number of times. So my favorite for last, Hyper-V. So 2008 R2 SP1 delivered a great hypervisor. Live migration, dynamic memory, remote FX, very powerful. Great performance of virtual hard disks, basically on par with direct attached pass-through storage. 2012 builds on all of that. So think scalability. Think in terms of a single VM. So a single VM can now have 64 virtual CPUs, 1 terabyte of RAM, and hundreds of 64 terabyte virtual hard disk files using the new VHDX format. So just that one VM, 64 virtual CPUs, a terabyte of RAM, huge virtual hard disks. So now pretty much any workload you can imagine could be virtualized in a Hyper-V virtual machine. There's really nothing I could not virtualize. But also think of scaling out. I can have 64 hosts in a cluster now, so I've gone from 16 to 64. Now when I talk about 64 virtual CPUs, there's an interesting point comes up, and that's NUMA, non-uniform memory access. If you look at the physical topology of a motherboard with lots and lots of processor sockets, the way most work is certain processor sockets have a direct connection to certain blocks of memory, and they're the best performing. They don't have to hop between different processors. That NUMA topology is passed into the virtual machine as well. So if there's a NUMA-aware application running inside that VM, it knows about the virtual procs and the memory that it's being used, and it can make the right decisions to get the very best performance. So carrying on performance, virtual fiber channel. I can now have in my virtual machines access through to a fiber channel SAN. I support SOIOV. So SOIOV is a fairly new networking technology that lets a physical network card basically act as if it's multiple network cards. It has things called virtual functions, and each virtual function can be passed directly through to a virtual machine. Now what's great here, I would normally hate this idea. The idea of mapping a virtual machine directly to something on the hardware breaks abstraction, which means, well, does that break mobility? I can now no longer move this VM between servers. This doesn't. Even though I directly map through to this hardware, behind the scenes, it also keeps a connection through the Hyper-V switch. So if I move this VM, it switches it over to the Hyper-V switch, does a live migration, checks on the new box if there's SOIOV connectivity. If there is, great. If there isn't, it stays on the Hyper-V switch. So bare metal performance. Network virtualization, the ability that, again, if I talk abstraction, most of the times in virtualization, we don't abstract the network. The IP addresses, the VLANs have to match the physical network fabric. No, they don't. I can create a red network, a blue network, completely abstracted from the physical network. I can move VMs between data centers, move them out into the public cloud, make sure 2 different tenants can never see each other using overlapping IP address ranges, all through network virtualization, completely abstracting the virtual machine's network view from the physical fabric. I have native NIC teaming, feature that people have been calling for a very long time. Again, I jump into my server manager, I can look at all my servers and I can configure the NIC teaming. So again, this is from my Windows 8 box. I've got a NIC teaming created on this box of 2 NICs in my team. Created this VM team. And there's very different attributes we can do in here. So I can use LACP for the teaming mode, static teaming, different types of load balancing. Now, this does not mean NIC teaming from a network driver has gone away. People like Intel, for example, differentiate some of their capabilities because of their NIC teaming capabilities in their driver. But you have a choice. I can choose to use the driver's NIC teaming, and that will be supported by the driver vendor, or I can use the Microsoft NIC teaming, which I can do through the GUI or through PowerShell. It's completely up to you. SMB support, live storage migration. So as I talked about before, I can now have virtual machines running over SMB. This virtual machine right here, its storage is actually running on a file share, just running over SMB. I can move storage now without actually having to shut down the VM. I can move it between SMB, between a SAM, between a NAS, whatever, with no downtime to the virtual machine at all. So I can do a live storage move. If I delete snapshots, it will merge in the various snapshot storage behind the scenes. So I don't have to shut down a VM to merge the storage that's associated with a snapshot now. It's a complete mobility. We had live migration already. 2008 R2, I could move a VM between nodes in a cluster that's using shared storage with no downtime. Now I can move a virtual machine between any 2 Windows 2012 hosts without any shared storage, without any cluster, with no downtime. As long as there's a 1 gig network connection between them, it will effectively copies the storage over and keeps it synchronized, then copies the memory over, keeps it synchronized, and then the VM is moved with no downtime to the virtual machine whatsoever. So let's just say this is, I've got a VM here, XP01. So I'm gonna connect to that. I create a very small little window. I'm just going to connect to this virtual machine. So I'm using RDP to connect into this VM. Now what I'm going to do here is I'm going to move it. So I'm going to move the VM to another host. I'm going to move all the storage as well. I select on the remote box where I want to move it to. Create a folder, or if I've already got a folder, because I've done this migration a couple of times before. And say go. So it's now going to start moving that VM. So if I look at my task manager, and look at my network, I'll see my live migration network goes through the roof. This is copying the storage over. So it's copying all of the storage of that VHD. But meanwhile, I'm still using it. I can go games, terrible at Minesweeper. I could take a tour of Windows XP. I really don't want to do that. I can do whatever I want. And meanwhile, I just carry on using this. Copying over all of the storage just in the background. I just carry on using the virtual machine. And I can see here the network is still going. If I was to look at the Hyper-V, it's still performing that move. Now what I'll see at a certain point is this traffic would drop. Once it's completed really moving the storage, and then it would do a memory copy. So I can see here moving virtual machine and storage, still performing that move, still carry on using it. So there's no interruption to the usage of this virtual machine at all. Once it finishes copying the storage, it's then going to go and copy the memory of the virtual machine. So we see a little drop off there, still using the VM. So that's basically the storage finished copying. Now it's copying the memory of the virtual machine over. So it's keeping it synchronized, but again, I'm still using it. I'm still in here. And then once it finishes copying the memory, it's finished. Oh, that was bad luck. I'm still connected to this VM. Finished moving. If I look at Hyper-V, it's gone. It's now over here on its local storage. And these two machines are not clustered. There's no relationship between them whatsoever. A shared nothing live migration. I didn't get disconnected. My work was not interrupted. And I used XP to demonstrate there's no reliance on the guest operating system. This could be a Linux VM, an XP VM, a Windows 2012 VM. It does not matter. There is no reliance on that whatsoever. We also introduced something called Hyper-V Replica. So if you think disaster recovery, now some organizations have synchronous or asynchronous SAN replication, which is great, but that can be very, very expensive. It needs dedicated hardware, dedicated networking. Hyper-V Replica allows an in-box replication of a virtual machine every 5 minutes. So every 5 minutes it's going to send the changes to the virtual machine storage to another Hyper-V server. So this is easy just to show. So if I look over here on my Hyper-V box, I have this server replicated. So you can see it's currently replicating. The replica VM is over here. So the replica is turned off because it's basically waiting if it would ever need to be used. But I can see not only does it replicate every 5 minutes, I can optionally say, hey, every hour create a snapshot. So I have various point in time history copies. I can also ask it to use VSS periodically. So it actually tells the virtual machine, like it was doing a backup, hey, run all the VSS writers, flush everything out to disk to make sure in an app consistent state, and then do a replication. This would give me the highest level of assurance if I had to actually use that virtual machine in a disaster, it would be usable. See, it's just got some changes, it merged them in, and then it carried on about its way every 5 minutes. So in an unplanned disaster, the worst case, hole in the ground, I might lose 5 minutes of data. So the recovery point objective would be 5 minutes. In a planned scenario, I don't lose anything. I can actually say, hey, look, I want to do a planned failover. It would shut down the VM, send any remaining delta changes to the disks over, start the VM on this side, and then reverse the replication. So no downtime, it would automatically reverse the replication. In an unplanned, I would have to start it on this side, and yes, I may lose some data. I can do a test failover. If I do a test failover, it will basically create a clone of the virtual machine. So it would keep replicating the original, keep this useful for DR. It will create another virtual machine using this as the basis so I can test my failover process. Now most disaster recovery locations are a separate building, otherwise they're not very useful. So there's going to be a separate network. I can configure failover TCP/IP configuration. So if I did have to perform a failover, this IP information would be injected into the virtual machine in the event of a failover, so it can communicate on my disaster recovery network. Now, I've really just scratched the surface. I mean, the amount of changes in Hyper-V are enormous. The amount of changes in Windows Server 2012 are enormous. There's great Linux support, which surprises people, but Microsoft has a team of people supporting Linux. The Microsoft integration services for Hyper-V are becoming a core part of the next version of the Linux distribution. It's going to be just a core part of that. But they're my top 10. I mean, that's what I think are the coolest features in there. But there's a 10.1. and it is System Center 2012. If you're using Windows Server 2012, you want System Center 2012, and SP1 adds full support for Windows Server 2012 and Windows 8. And this really gives you that full enterprise management of not just Hyper-V. It's the physical equipment, the network, the servers, the storage, the operating system, the applications, your custom applications. It's heterogeneous. This has management for Linux, Unix, Mac, ESX, Zen Server. Orchestrator can connect into pretty much any component of your environment. So I don't want to talk about System Center 2012 right now, that's not my goal. But the key point is, this is huge. Windows Server 2012 is a phenomenal operating system, phenomenal hypervisor. Truly is a platform for any kind of cloud. But to get the most from it, you want to be using System Center 2012. That is your enterprise management. And you'll see here it connects to Windows Azure as well. I can deploy apps and services between my on and my off-premise capabilities. So I hope you enjoyed the presentation. That is my top 10. I'm happy to receive emails at john@saviltech.com if you disagree or think I should add some. Maybe I'll do the next 20 features of Windows Server 2012. But I hope this was educational. I hope it was useful. And I look forward to hearing from you. Thank you.